Okay, I want to describe one of the typical types of problems you see when you're analyzing real data. So what I've got here is the rating curve for a river in Mississippi. You don't really need to, Alabama, sorry. You don't really need to know what it is, but I want to make the point that this is what the rating curve looks like. I mean, it's sort of strange, right? It almost looks like there are two separate rating curves, right? You can sort of define one that sort of goes like this to these data. Pretty nice. And then there's almost like another one, right, that goes through these other data like this. Like this. And if we fit a curve through these, we're going to get a curve that doesn't really fit through either of those, right? So for example, if I were to try to fit a curve here, I'd select my data and add a trend line, stick a power one. You can see that my curve doesn't really go through any of the data. It goes right between the two of them, and that's not what I want. And this is actually a fairly common situation, and it arises when there's been some change made to the channel, to the bottom of the channel, to something upstream that fundamentally changes the nature of the rating curve. So in other words, what we've got here in reality is two separate rating curves from two different times. And since we're interested in projecting this to the future, we want to use the rating curve that is the most recent rating curve. So we have to find out what that is, and when we fit a curve through our data, we want to use only the data for the most recent rating curve. And this is how we're going to go about doing it. So we're going to take all of our data now, and I'm going to click on the first and the last here, and I'm going to actually sort this now. Actually, let me pick it. I'll get the headers here so it's clear what we're doing here. I'm going to select all of my data, and I am going to sort them by, my data has headers now. I'm going to sort this by date, from the youngest, newest to the oldest. Okay, so now here you can see that the newest data are from 2022, and we go all the way back, in this case, down to 1991. And what I'm going to do, remember what I'm plotting for the rating curve. These are the two columns I've been plotting here. Discharge on the x-axis versus stage on the y-axis. And now I'm going to try to figure out, okay, what portion of which of these data, the most recent data, correspond to which of these rating curves. So I'll show you what I mean. Let's just try to plot, overlay on this all the data since the year 2010. Okay, so there we go. So this is all the data after 2011 and past. So I'm going to just give this a color there. I'm just going to try to just plot these data. I'm going to overlay that on top of these data here. And the way I do that again is I'll select on my data, select data, and this is in a Mac now. It's similar in a PC. I'm going to add a data series. There it is. And I'm going to call that new data series. I'm going to call it newest. These are the newest data. And the X values of this data will be the X values here, and the Y values will be the Y values, the stage. And I hit OK. And now in orange, I can see what those values in red here, the newest values, look like. And it does look like, I've already sort of figured out now, that in fact the newer of the two rating curves is the lower one. So I want to now select all of the data that correspond to that newer rating curve so that I can fit a curve just through the newer data. And it looks like it goes back somewhat further in time. And I can sort of play this game. I go up there and look very carefully. This is what, 15,600. That's this point here at in 2009. This point here is at, oh, that's the one I just picked, isn't it? What's this one over here? Oh, it's not 15. Oh, sorry, 17,200. So that would be, did I read that right? This one right there, 12,300. That's the one over here. Okay, so it looks like I maybe want to go all the way back down. Let's try go down to at least here and see if that works. So I'm going to now select data from 2004 on. So all I need to do now is I'm just going to go in and I'm going to tweak these boundaries for newest, right? I can redefine them if you want. So I'm going to go for the X, it's going to go, X-axis is going to go there. And the y-axis, y values are going to go down to there. So now we've got all the data since 2004. And look, we've gotten a lot better. Looks like we're missing just one data point. This one right there probably. Let's see if we can check it here. This point right there is 84.50. There it is. It's this one here. So all I need to do is I'll include this one as well. So I'm going to select all the data from 2003 on. So I'm just going to tweak this a little bit. I'm going to go pick my X value. Oops. Try this again. On the newest is the one I want to tweak. I want to go all the way down to there. And my Y values all the way down to here. And there, that looks pretty good. So apparently something profound happened at the stream or at the river in about the year 2002, and that fundamentally changed the rating curve. So the rating curve I want to use for predicting the future is the newest one, and that's the one that I can fit to the data that are shown in orange. So I'm going to right click on the data point here, and I'm going to add a trend line, and we'll try power because that's the one that normally works, and that looks pretty darn good. I'll forecast it ahead, just maybe 5,000, just to show you what I mean, how the extrapolation will look. And what do we look? And that looks really good, right? So that clearly does a good job of fitting our most recent data. We're not really interested in the old rating curve because that's not relevant to the future. So this is the rating curve we will need to use to make predictions of the stage versus discharge in the future.